Okay, on to section 5-3, adding and subtracting rational expressions. So, when you add and subtract fractions, it tends to be a little bit more, I wouldn't say complicated, just a little bit different than multiplying and dividing rational expressions or fractions, but there are certainly easier methods to use that we can make the whole process easier. So one would be fraction busters, one would be bow tie method. All of those are going to make that easier. And just like they work with fractions that only have numbers going on, they also work with rational expressions. So we know that when we add and subtract fractions, we must have a common denominator. And when we do, we can just add the numerators. So 1 plus 5 is 6. 6 divided by 3 is 2. So that simplifies that. We can also use that with a variable. So when you're subtracting, one thing I would caution you, sometimes I prefer to write this. It's kind of the only time that I can deal with double signs. I typically don't like them. I think with rational expressions, they're pretty helpful. In a simple one, you wouldn't necessarily need it, but when they get to where this numerator has multiple terms in it, one of those terms always gets forgotten about. So I think it's easier to write it as a plus a negative. So x minus 5 over 3. We'll get to that a little bit later. 7 plus 5 is 12. 3y squared is our common denominator on the bottom. This can be simplified. 3 goes into 12 4 times. So your resulting answer is 4 over y squared. Okay. So let's go do a couple practices of those. Really nice when the denominator is the same. Super simple. 9 minus 3 is 6 over 3x times 2x plus 1. So here's a case where you could multiply that out if you wanted to, but the 3 goes into 6 twice, and then you would have 2 over x times 2x plus 1. Now you're going to be tempted to cancel that 2 out, but what happens if we actually use distributive property and multiply that bottom out? We would have 2x squared plus x. 2 is not a number that goes into all three terms, so you wouldn't be able to cancel that 2 out either way. So I would just leave it in factor form. I think it's cleaner, simpler. Okay, second one. At this point, you should be recognizing that y squared minus 9 and the product of y plus 3 and y minus 3 are exactly the same thing. So that is a common denominator. You can always either multiply those together or factor those if you need to see that they're the same. But otherwise, you can just add your numerators, 2y plus 5, and I'm just going to put it in the easiest form there is, which is y squared minus 9. Nothing, 2 and 5 don't have a common factor, so there's nothing that I would be able to factor out regardless of which form I put it in down here. Okay, so for unlike denominators, I really want you to think about bow tie method because it really, really works really well. When you have more than 2 fractions going on, not so much, but the other thing I want you to think about is fraction busters. One of those 2 methods is going to be your friend. So let's kind of try both here. So for bow tie method, can't write it right there because it's going to be right in my way. Okay. So with bow tie method, you are going to multiply your denominators together. So that gives us a 21. Then on the diagonals, you're going to multiply and add those resulting products together. So 3 times 1 is 3. 7 times 5 is 35. So our answer is 38 over 21. Boom. That easy. Yes, it works for rational expressions. Yes, it works for complex rational expressions. It works great. So let's go ahead and try it on our middle equation and see what happens here. So same thing. 7 times 3 is 21. Let's put the negative up here so we remember what we're doing. Once you have that sign up there, you're not going to worry about whether you're multiplying positives or negatives. You're just going to multiply. So 3 times x is 3x. 7 times 5 is 35. So we would have 3x minus 35 on the top and bottom. Okay. So I think that it's the easiest way. What you're really doing, you're trying to find a common denominator still. Okay, so the common denominator of 3 and x is 3x. So that's why when you multiply it across, you're by default coming up with your common denominator. When you multiply on the diagonals, you're basically multiplying what's missing from this one. So in this, we need this denominator to be 3x. It's missing the 3, which is why we're multiplying that 3 to the 4. Okay, so that's going to give us 12. Same thing here. This is missing the x. It's what we need to multiply this numerator by. So that gives us 5x. So you get 12 minus 5x. Again, the x cannot be canceled because it does not occur in every term. Okay. So even if it gets to the point where you need to simplify it later, it's okay. Bow tie method works great for this. So put the negative up there because we're subtracting. 3y squared times 9y would be 27y cubed. If it becomes something that we need to cancel, we'll deal with it in a minute. It's all right. 9y times 7 would be 63y. And 3y squared times 5 would be 15y squared. So here's a perfect example. We've got 63y minus 15y squared. Now there are definitely things that we can cancel out here. So if I'm looking at my 63, 15, and 27, I know that 3 goes into each one of those. So I'll go ahead and simplify those. That's fine. I also know that I've got a y occurring in every term, so I can cancel out a y. So what I have left is 21 minus 5y over 9y squared. So even with something more complex, it still works for bow tie method. Now, if you're not going to do bow tie method, what you're really doing is fraction busters, and honestly, bow tie method is a form of fraction busters. So if I was going to do fraction busters and I needed to know a denominator that x minus 4 and 3x would both go into, the easiest way to find denominators is just multiply them together. So that would be 3x times x minus 4. Don't multiply it out, it just makes things more complicated. And the way I would have to do that is to multiply this by 3x and this by x minus 4, which essentially is fraction busters, is what we just did. So we can do that. So 27x plus 3 times x minus 4. Now be careful here. You cannot just cancel those because that x minus 4 factor would have to belong to this too, and it doesn't. So in this case, we do need to multiply that out, and we get 3x minus 12. And here, and let's put those together. So we have 30x minus 12 and 3x times x minus 4. Now we can simplify this because I can take a 6 out of both of those. So that gives me 6 times 5x minus 2 over 3x times x minus 4. Then my 3 and my 6 cancel. So I end up with 2 times 5x minus 2 over x minus 4. Okay. Now, here's a case where maybe fraction busters you don't want to do, but you could. If we had factored this denominator here, we know that that would be y plus 3 and y minus 3. So for my common denominator, it means that I need to have each of these factors occur at least once. So I'm going to write down the factors that I need. So I need a y plus 3, a y minus 3, and a 4. And let's go ahead and put him out in front where he usually is. And then I've just got to figure out which one is missing, right? So here I need all 3, but it's missing the 4. So I've got to multiply that 2y by the 4. So I've got 4 times 2y minus, and then on this side I've got the 4 and the y minus 3. What it's missing is the y plus 3. So this is going to be multiplied by y plus 3. So minus 5 times y plus 3. Now I can go ahead and multiply that out and simplify anything that will simplify for me. So I get 8y minus 5y minus 15 over 4 times y. I'm just going to leave it in factored form for now, see what happens. So up here, 8y minus 5y would give me 3y. And then I can in fact cancel or sorry, factor out a 3 from both of those, and I would get y, 3 times y minus 5 over 4 y plus 3, y minus 3. And nothing else here can cancel. So yes, I could have used bow tie method. What would have happened was I would have had an extra y minus 3 going on had I done bow tie method, which would eventually have canceled out. So if you went the bow tie method, you would still be fine. Either way that you choose to do that will work perfectly. Okay, here's a really good example of why I encourage you to switch this to plus a negative. If I subtract a polynomial, remember that that changes the signs of everything in here. So what you can do is change this to a positive and then flip your signs here. So like we did up here, we changed this to a positive and flipped it to -5. Okay, so what that really means that you're doing, you're multiplying by a -1. So negative times a negative is a positive. Negative times a negative is a positive 1. So really, you can switch this to that now. So that's one thing we can do. Let's go ahead and factor things out, because then we can see what we need and what we don't need. So 2 and x minus 1. And this factors to x minus 3 and x minus 1. So the three unique factors that I've got going on down here are 2, x minus 1, and x minus 3. So that's going to be my common denominator. And then I've just got to figure out which each numerator is missing. So this one's got a 2 and an x minus 1. It's missing the x minus 3. So I've got to multiply this by x minus 3. So I've got x plus 2 times x minus 3. And then on the right-hand side, I've got x minus 3 and x minus 1. It's missing the 2. So I've got to multiply that by 2. So I've got plus 2 times 2x plus 1. So now let's clean this all up. And I don't know that anything's going to factor out, so we're just going to actually go ahead and multiply everything and see. So let's multiply this together first. We get x squared minus x minus 6 plus 4x plus 2. And get this all cleaned up. So I've got x squared, 4x minus x is 3x, and -6 plus 2 is -4. That is going to be a polynomial that's factorable. Oops, sorry. That's going to be a polynomial that's factorable. Let's clean up the bottom first and get that situated, and then we'll deal with it. So actually, I'm going to leave this in factored form for now. I have a feeling that one of those is going to look the same. So now if I factor the top, let's take this over here. The two numbers that multiply to -4 that add up to 3 would be x plus 4 and x minus 1. And then on the bottom I have 2, x minus 3, and x minus 1. So this is the reason I kind of leave that denominator factored, because I had a feeling it was going to factor out. So now I've got the x minus 1 that factors in both cases. So I've got x plus 4 over 2 times x minus 3. Okay, don't feel overwhelmed. They take a little bit of practice, but not too terribly difficult. Oh, Miss V, what are you doing to me? What is 5 fractions all at once? 1, 2, 3, 4, 5. Oh, okay. So let's show you method 1 and method 2. Okay, method 1, we could do a couple of things. We could use bow tie to get that top and bottom, which I think I'm going to do. So if we use bow tie in the numerator, let's just deal with the numerator first. We have 3 times 2, which would give me 6. 2 times 2 is 4. 3 times 1 is 3, so that would give me 7 over 6. Actually, not so bad. We don't have variables going on yet, so it's a little bit bad. Okay, same thing on the bottom. Anytime you see fractions within fractions within fractions, you're going to have a little bit of anxiety, but I'm going to try and get rid of that anxiety for you quickly. So 3 times 5 is 15. 4 times 5 is 20. Minus 3 times 2 is 6, which would be 14. Now I can just, when you divide by a fraction, it's the same as multiplying by the reciprocal. So I'm going to take this bottom fraction, flip it over, get rid of that, and now I can cancel and multiply. And now is fine. So I get 5 over 4. Okay, not so terrible, a little bit labor intensive. Then you're looking down here going, oh Lord, then she's going to put variables in it, and oh good gravy, then she's going to put binomials in it. So let's get an easier method to do that. I want you to think about that fraction buster thing again, okay? But now you've got 1, 2, 3 unique denominators going on. And so if we use that whole fraction buster idea, let's get rid of all 3 denominators at once. Wouldn't that be magical? So let's think of a number that 2, 3, and 5 all go into. The easiest way to do that is multiply them together. 5 times 2 is 10, times 3 is 30. So let's multiply this entire fraction by 30 over 30. So watch what happens. So 3 goes into 30 10 times 2 is 20. This whole mess turned into that. Okay. Half of 30 is 15. 20 plus 15 is 35. I just turned all of that into one simple number. Okay, let's do it again. 3 goes into 30 10 times 4 would give me 40. Minus 5 goes into 30 6 times 2, which would be 12. 40 minus 12 is 28. So now I skipped out on this whole step where I've still got a fraction divided by a fraction. I already got to nice whole numbers right here. So much easier, so much better. So now I just need to reduce that by 7s, and that gives me 5 over 4. Same exact problem, done a different way, kind of a different application of fraction busters, but one that I really like, and I think method 2 is awesome. I would definitely recommend it. So let's go on to something that's a little bit more complicated to look at, but not complicated to solve. So let's find so method 2 means find a common factor of all the denominators. Okay, so in this case we've got x times 1 times 3x times 5. So let's just deal with coefficients first. 1 times 3 is 3, times 5 is 15. So I know I've got a 15 involved there. And then I just need the x, because I need something that x can go into both on the top and the bottom. So that common factor that I'm going to use is 15x. Okay, so now let's go one at a time. The x's cancel. Here, x goes into x once. Times 15 is 15, times 2 is 30. Oh, look at that. That was awesome. 1 goes into 15x, obviously 15x, times 3 is 45x. Look how nicely that cleaned up. 3x goes into 15x 5 times 4 is 20, minus 5 goes into 15x 3 times 7 is 21. So that all simplifies down to 30 plus 45x over negative 1. And what you really can do is then just divide each of those by negative 1, so you get 30 minus 45x. Really like that method. I think it makes everything so much easier. And when you see what it does with this, you're going to be even happier. So let's think about, so I've got x plus 2, x minus 2, and x squared minus 4. I hope by now that you recognize this is the same as x plus 2 times x minus 2. So that right there will be our common denominator, the x squared minus 4, or x squared x plus 2, x minus 2. Okay, so we are going to, I'm going to put it in factored form, because then it's easier to see what's going to cancel out, over x plus 2, x minus 2. Okay. So let's go first things first. So x plus 2, the x plus 2's cancel right there. So those go away. And on the top, all I have is 2 times x minus 2. That's it. Simple. X squared minus 4 is in fact the same thing as x plus 2 times x minus 2. So those in that case cancel. And all I have is 4. minus 7 times something. X minus 2 and x minus 2 cancel. All I have left is x plus 2. So all of that mess turned down to this, which is simple. So let's multiply this out, see if anything else we can get to cancel. So 2x minus 4 over 4 minus 7x minus 14. So that's the same as negative 7x minus 10. Let's see. 4 minus 14 is negative 10 and negative 7x. Okay, good. Just double checking myself. So we've got 2x minus 4 over negative 7x minus 10. I could factor a 2 out of here. So you could also write it as 2 times x minus 2. That would be fine. But a 2 doesn't cancel out of all 4 terms. So I can actually leave it like that as well. Done. So much simpler. Okay, so the key is to factor things first, and then that will be easier for you to use that method too. Okay, so let's factor this. We get x minus 4 and x minus 4 is the same as that x squared minus 8x plus 16. So this x minus 4 can go into x minus 4 times x minus 4, obviously. So this is now my common denominator. I'm going to multiply top and bottom by, oh, I'm sorry, I'm getting into complex division, and that's not what I needed to do. Same idea, actually same idea, but my common denominator, same idea actually, sorry, got ahead of myself, is that. This is not missing anything, this side, so it just needs that 15x brought over. Over here, I've got 8. It's missing one of the x minus 4, so that's what I've got to multiply by. Now I kind of need to clean up that top a little bit. So I get negative 15x minus 8x plus 32, which gives me negative 23x plus 32. And on the bottom I just have x minus 4. It would have been over here too. Just rewriting. And x minus 4. Okay. Here we've got same denominators, nice and easy, just add the top, 8 over 2x plus 1. Okay, now let's get to the complex fractions. I got a little excited and moved on ahead when I shouldn't have. So let's factor all of our denominators just so we can see really easily what we have to work with. So x factors out of both of those, so I get x times x minus 2. And x minus 2 obviously go into x times x minus 2. So that is going to be what I multiply top and bottom by. So now let's see what's missing. So x here cancels. So on the top I've just got 3 times x minus 2. And then on my right side fraction, the x minus 2 cancels. So all I have left to multiply together is 5 and x. And then on the bottom, this whole thing cancels with that, so all I've got is a 6, which is great because I have x times x minus 2 both in both spots. They cancel out. All I have left is a 6. So now let's clean this up a little bit. I get 3x minus 6 plus 5x over 6, which gives me 8x minus 6 over 6. I can now here's a perfect example. I've got a number in every term that has a common factor of 2. So I can take a 2 out of each of those, and I would get 4x minus 3 over 3. Okay? And one more time, this is going to be bow tie method. That's what I'm going to use. So x plus 1 times 1 is just x plus 1. 1 times 5 is 5. X times x plus 1. And I'm going to multiply that out, so I'm going to get 5 plus x squared plus x. And I'm going to kind of move that around just so it's more in standard form. I get x squared plus x plus 5 over x plus 1. And this is a prime equation. There's nothing, the only things that multiply to 5 are 5 and 1. Sorry about that. Are 5 and 1. And so that doesn't add up to the 1 in the middle. So this is as simple as it gets. There you go. adding, subtracting rational expressions.